Hey guys, welcome to Codeforces Everyday until GM day 74. Today we are going to be doing this around 1090 Div 4 contest. A minute before it starts, hopefully we do alright. Hopefully we gain rating this time. I've done a few warm-up problems just to get my brain going. Now I think I got a good amount of sleep. It's not good. I woke up too early and I couldn't go back to sleep. But I tried going to sleep earlier for this contest, and I did a few laps around my apartment because apparently physical exercise helps with your heart rate or something. I don't know, but I'm starting to put together a pre-contest like routine. Just trying stuff out, seeing what gets me in the right mental state to solve problems. Let's commit this real quick. 16 seconds before it starts, let's clear my whiteboard. Let's remove everything I don't need. I think that's it. And 4 seconds. Alright, I'm ready. Okay, let's go. The 67th integer problem. Okay. Welcome to New World. Okay. You're given an integer x, your task is to choose an integer y such that the value of min xy is maximized. Okay, we take in the test case t, and then we take in an in, or a x. What are we supposed to do? They love 6-7 these days for some reason. Given x, choose a y such that the value of min is xy is maximized. So we're given 1. Our y is 2 because... Okay, so we just print x plus 1. Am I tripping? Problems. B. Boom, boom. Okay. We take in input t and then an array. So it's like this, and then I can grab this. List. Just check if A worked. I failed. Okay, let's take a better look at this. Minimum is maximized. 3, 4, 5, 6. Why is why? Why does this not work? Just why such min is maximized? All x greater than equal to a. It feels right. Like what exactly is wrong with this? This is not a good start, guys. I mean, my code is a bit too simple. Choose an integer x such that the minimum between x and y. Yeah. Why does this not work? I mean, we can literally print the same answer, right? Like, you can choose any integer. I guess it fails x is 6, 7. Hello. Let's submit, guys. I mean, that's gotta be it. But that's on me for not reading the question clearly. You're given 7 integers. You must negate 6 out of 7 integers. That is multiple. Okay. Find the maximum possible sum of A. So, this is a sorting problem. Um, so we sum everything. Print sum A minus A negative 1. Remove the last value. Then this is, all this is negative. But we add the last value. Thank you for messaging me. Nico. Oh yeah, the model got a concussion. Okay, how is this one still wrong? I don't understand. Oh, I guess we could use a negative number. Right? Negative 67? Why aren't we using negative for these, though? Wait, am I tripping? The smallest will always be this. Right? No, that doesn't have to do with anything. I really don't understand why this is wrong. And wait, my A is right. Wait, what the fuck? I'm so confused. Oh, did it? I guess it just didn't run. No, hurry up. Is my B correct? Bro, this is pissing me off. B, C. I wish they got better servers for contests because it's just annoying, man. Like having to wait for to see if your submission's right or not. Like this one still hasn't finished grading. You're given an integer n, you must construct a permutation of length 3n. If you partition the permutation into n contiguous blocks with 3 elements, the sum of the medians of these blocks are maximized. Formally, you must construct a permutation v of length 3n such this is maximized. Okay, so we take in t and then an n, so it's the same as this one. Still great. Median. The sum of the median from 0 to n minus 1 is maximized. Okay, and the first test case, median of 1, 3, 4, 3i. What? You must construct a permutation length 3n, so 6, such that possible sum of medians. Three I, so 0, 1, or it's 0, 1, 2, 3. If it's 1, then if I is 1, then it's 2, 3, 4. So this, I guess this is maximized, okay. And then this is just this. Those are 1, 2, 3. Median means middle. So we maximize the sum of the middle numbers. Y is given 3n. Y is, huh? It's because we can only achieve the sum of medians when n equals 1 is 2. What does this mean? Okay, let's look at this case. I don't understand this either. Median means, wait, yeah, I do. Oh, because it has to be sorted. 1, 2, 3, so this is 2. Yeah, and then this is 2, 4, 5, so 4, and then 4 plus 8 plus 6. Okay, so you want the number, it's a permutation, right? We want, this is greedy. We want like 1, 2, 3, 4, 5, 6. We want 6, 5 to be touching, and we can shove 1 in here. 3, 4 to be touching, and then shove 2 in here, I think. So if we had bigger numbers, 1, 2, 3, 4, 5, 6, 7. So this, okay, this is n equals 2, n equals 4 would mean we need 8, 9, 10, 11, 12. Then we'd have these two and this, these two and this, these two and this, these two and this. Right. So in order to do this, we simply just for I in range in, temp equals I temp dot append 3n minus 3 times n. So if n is 4, we'd have 12 minus 1 minus I, and then to print dot append temp print to print. This ain't right. 3 times n is 12. I should start at 1 and plus 1. 1, 5, 4. So does this work? This doesn't work. This doesn't work either. So, okay. Okay, I can just do. It's a little annoying, but it's okay. Temp O 1 2. There we go. Now why do I have double sevens in here? That's not good. Start at 8. We have no 6. So n minus swan. This one just n minus I simplified. This will have 5, 4, which is 11. They got 8s. Oh, we reuse 5 here? That's not good. Y, I. It's 12 minus. Okay, wait, no, it's 6 minus 1 is 5. What is this? Six minus I. One, 5, 1, 6, 5, 2, 3, 4. This implementation is so sloppy. Mm. Temp equals I, current index, 3 times in minus I plus 1. 3 times in minus I. Extend temp. Does this work? 6. This doesn't work. Okay, do I need to track a like low value equals 1, high equals 3 times in, and then low, high minus 1, and then low plus equals 1, high minus equals 2, and then for I in range in 6. Okay, now we get 5, 3, 8, 2, then this should be 8, 6, 4. I think this is right. Uh, uh, okay, we did get B. Each test case, T in, so it's the same as this. And then construct a sequence A containing n integers such GCD is distinct over sequence A. Okay. In the first test case sequence, 162 is possible because GCD 16 is not equal to 62. Wait. Such that is distinct. Okay. 3. Length 3 is 5. Is this not just a prime number generator? It's not a prime number generator. It's a even number generator. No. Like for GCDs to be distinct, we should do like 2, 4, 6, 8, right? Because GCD is 2, GCD. Wait, am I tripping? Not 6. GCD is 4. Well, we can maybe do like 2, 6, 12. Or multiples of 6. We just have to make it's like 2 to the n. I feel like. For the numbers you generate. C pass, nice. Or can we just do I times I plus 1, 2 times 3, and then is 6. 12 is like 2. And then 4 times 5 is 20. This is like GCD is 2, GCD is 6, GCD is 4. I think this works. Or we can do 2 to the n. I think that also works. 8, 16. Right? Both of them work, right? I'm not tripping. What's the bounds though? 2 to the n might be too big. I don't think it matters. Oh, we should start. Implementing, I guess. 2. So array is 2 to the power of I for I in range from 1 to n plus 1. And then print star to print. Okay. TNA. It's over. Did I not do? Okay. This is good enough. Okay. Given an array initially containing n non-negative integers, you can perform the following operation exactly n minus 1 times select an index of a XOR. Okay, I practiced this yesterday. Let x equals ai set. So select an index. Current length of a. Array a. Okay. Set aj equals aj XOR x. In the second test case, okay, I'll put a single into maximum possible value of the final element. Remove from the array. Okay. Select 3. Assigning an index I of a, the current length of a. So the current length of a is 3. We select 3, let x equals 3, then set 3 equals 3, set each value equals minus 3, okay. Select 2. What do we want to do? Maximum possible value. The final. So, okay. 6767. If it's all the same, if it's the same number, it's 0. D is wrong. Okay, let's go back to D real quick. Why would this be wrong? 4. 2, 4. GCD is 2. I don't understand where mine fails. It might be a constraint issue? Might be this. Okay, yeah, it is that. It has to be that. Oh fuck! Why didn't I just look at that earlier? I should have just gone with my first idea. I thought I was being smart. It's I times I plus 1 for I in range from 1 to n plus 1. I think, because this is 2. 2, 6, 4. I think this is correct. Back to E. This one is actually kind of difficult. N minus 1 times. It's wrong still. Why is this wrong? Okay. Why is this wrong? I thought at least this one would be right. Uh, 7, 1, 69. Where did they cross over in my formula? Did they cross over? I feel like they don't cross over though. Like, what? This is 5. 6 is 30. 6 is 10. Hmm. Next, n. So a needs to be less than or equal to 10 to the 18. I don't get anywhere close to 10 to the 18, right? N is... Wrong question. 10 to the 4. So at most I go 10 to the 4 times 10 to the 4 plus 1, which is 5. No, it's 1. It's 5 digits, 4 zeros, which would be 10 to the 8. It's within the limits. Why is this failing? I don't get it. Is there... Maybe there's just some duplicate it catches onto. 5. Maybe. Maybe we can do some sort of LCM approach. Like if we have 1 and 2. Or, let me think. If I is 1, A is 2. But if... Wait, oh, our thing does fail, I think. So our next number is 6, 7, which is 42. GCD of this is 6. This doesn't work. So 2 to the n is too high. This doesn't work. So, okay, yeah, okay. Ah, fuck, I should have checked one more. So what's the strategy now? It's... we want each GCD. We don't really want to skip numbers, right? We want 1, 2, 3, 4, 6, but we're allowed up to 10 to the 18. we will have 10 to the 4 digits, so how would you construct this sequence? I can't use 2 to the n because I'll run out of room. So we want each GCD to equal 1, 2, 3. So if we had 嗯 I'm stuck? One. This is a prime number question. Can I use prime numbers in any way? This might work with prime numbers, low-key. I probably need a seed. need a sieve? So all primes will be different, right? So in theory, I could just do the product of like two consecutive primes. So like it's 2, and then it's 2 times 3, 3 times 5, etc., right? GCD is 2, GCD is 3, and then GCD is 5. Yeah. I think this is cooking. Uh, we need primes up to 10 to the 4, so it's 10 to the 5 to be safe. Find range from 1 to n. We append the previous prime to, or times the current prime. Sure. Oh, I need to fix this. This is XOR. I need to do star star. Okay. I think this is right. Back to E. These are not easy anymore, which is to be expected. Runtime error. Runtime error on test 3. It's a runtime error, it's not a TLE. My seed is wrong. My template's wrong? It has to be. This looks correct. This is correct. This is correct. Seed of Eratosthenes. Oh, maybe I can. First of all, let's set that. And then mark the composites. This looks correct. And then we need to collect the prime numbers, right? 2n plus 1 if it is prime p. This is still correct. Okay, yeah. I don't know if that fixed my bug, but it's a runtime error. I think it's because I don't collect the square roots of n. So, no, it's still runtime erroring. What am I erroring on? Do I not have enough numbers? I don't have enough numbers. Not enough primes. I thought 10 to the power 5 would be safe. Ten followed by 5 zeros. That's 6 zeros. Okay. Okay, just have to tweak the permissions a little bit. Okay. I think this is a better seed implementation than my old one. Let's replace it. It's like slightly better. It's pretty much the same. I think. Or just in case. Yeah. Alright. To E. Still have an hour. Given the array, perform this. Blah 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 blah. Given an array. Non-negative. We do this in -1 times. We want the largest. XOR is exclusive OR, so the bits don't line up, right? Well, we know like 1 XOR 2 is 3. The order of the XOR doesn't matter. Two XOR 3 is 1. Select an element and remove it. So our first step is select an element and remove it. Our second step is recalculating the array. So the question is, which element should we remove? The greatest element or the smallest? In the second case, we select the greatest element, recalculated the array, select the greatest, recalculate the array. Now in this one, what do we do? XOR. So you pick. What do you pick? M. Pick 3. Pick 2. Pick 3, 2. 1 XOR 3 XOR 2 is 3. No. 1, 2 XOR 3 XOR 2. I need an XOR calculator. Oh, these suck. Wait, can I do multi-line? Where is it? 2 XOR 3 XOR 2 is 3. Because these guys cancel. Now, if I do something larger... Like, this case is terrible. Like, how am I even supposed to test this case? What is 3 XOR 2? Is 1. So 2 XOR 1 is 3. Okay, so this is a pattern. 2 XOR 3 XOR 2 is equal to 3. because these switch each other off. 2 XOR 1 is 3. 2 XOR 3 is 1. So say I take the first 3 here, 6, 7, 6, 7, 6, 6, 7, 1, 6, 7. Which one do we pick? We'll just pick a random one. So we pick 6, 7. We'll do 6, 7 XOR 6, 6, 7. 1, 6, 7 XOR 6, 6, 7. Oh my god. It's 728. $572, right? Seven. 6, 7 XOR 1, 6, 7. 228. Say I had 1, 2, 3, 4. So pick 2. 3, 1, 6. Then we pick this. 2, 7, 2 plus 1 equals 3. 4 bitwise, 3 equals 7, right? Yes. Okay, so this is the relationship that I was breaking down in my head. I think we only care about the last pick, right? Oh, wait, okay, let me think about this. This is cumulative. So our number at the end will be an XOR of everything else. What are we trying to do? The maximum possible final element. So what we should do is we should just simulate we try the 1 XOR 2 XOR 3. But then we're basically just trying every combination at this point, right? 0. Am I tripping? 0. 2 XOR 3 XOR 1. 2 XOR 3 XOR 1 is 0. 2 XOR 3 XOR 2. No, it doesn't behave how I thought it would. Does it? Because if we select 2, then select 3, then it's 1 XOR 2. All 3 changes as well, right? One, two, three, 4. Select 1. We select 1. 1 XOR 2 is 3. It's 2, 5. We select 2. Is it 1, 6? It's so hard to do in my head. Yes, it is. Okay. Then this gets 7. Okay. This is the same as 4 XOR 1 XOR 3 XOR 6. Right. No. It's 4 XOR 5. Wait. No, it's 4 XOR 1 equals 5. XOR 3 equals 6. This is 3. Or right. I don't feel like we need a data structure for this. Like a prefix, some sort of prefix structure. We could try every pair. We have 3. There's a brute force problem. Bro, I literally, let me see. Literally sent a message to my buddy like this or yesterday saying, can we do a lecture on bitwise operations, binary representation of in, and bit shifting? I feel like I've been running into a number of these problems lately and I'm not really good at them. I really need that lecture right now. Okay, but if we have it. right? This is in squared, but are in a small. So we're just trying every pair. Right. Right. Because this is why. Whenever you compare these two, the same flips have been done. So they actually cancel out. So at the end, it's basically doing this. I think. I can confirm nor deny, but I think this is correct. Where's the dashboard? Tree problem. That's not good. I do not have too much experience with trees. There's question mark. What am I doing? I'm losing it, guys. I'm losing it. Oh, we got E. Nice. Task is to construct a tree with rooted at node 1 such that exactly x nodes in... Wait, you're given two integers. Construct a tree with x plus y nodes rooted at node 1 such that exactly x nodes in the tree have even subtree, exactly y nodes in the tree have odd subtree. If multiple valid trees exist, you may output any of them. If there's no such tree, output no. Okay, so what's our input? T and x and y. Is over. Whatever. Okay, Lord. $100. I do not need this right now. If valid trees exist, you may output any of them. If no such tree, output no. Exactly X nodes in the tree have even subtree size. Exactly Y nodes in the tree have odd subtree size. Okay. Output yes. Output X plus Y minus 1. Oh my god. In the first test, the output tree is valid because node 1 has subtree size 2 and node 2 has subtree size 1. X plus Y. 1 has 1, so you're saying 1 odd, 1 even. It has 2 nodes, 1 odd, 1 even, so it's like TS. Right. This is for the fourth test case. 3, 4. Odd, even. One, 2, 3, 4, 5, 6, 7, 10. 4. Even. Odds. 1, 3, 5. Yeah, I'm kind of confused. The fourth test 3, 4. Nodes with even subtree size are 2, 4, 6. Nodes with odd subtree size are what is this? How is this 2, 4, 6? Nodes. 4 is 3. Okay, so when does it not exist? Third test case. 1, 2, 1, 2, 3, 4. The fifth and sixth test case. Why does sixth test case output no? I understand fifth. Okay, I don't understand the question then. The task X plus Y nodes. So we're saying construct a tree with 1 node, construct a tree with 2 nodes, such that X nodes in the tree have an even subtree. So 1 node in the tree has an even subtree and 1 node has an odd subtree. So if it's like this, we have 1 even, 1 odd, right? In the second test case, we're saying construct 2 even, 1 odd, size 3. But we're saying this is impossible. This is 1 This has two subtrees, right? Even subtree size. Even subtree, even size subtree in an array tree. Given an array tree of n vertices trees. I don't get it. I need a visual. Even number of nodes, right? So I think my understanding is correct. This has two nodes, this has one node. This has three, which is odd, and this each has one. So if I do like this is the only other possible construction, right? This would be 3, 2, 1. There's two odd, one even, which means this is impossible. So we should always have at least one odd. So if x is equal to 0, print no. Right? Second case, 2, 1. Two odds. What? It's like this, yes. And we should output there's an edge between nodes U and V. There's an edge between nodes U and V? The fuck does that mean? Bro, this is like my first graph problem. I don't know what I'm doing. And I need to use the restroom. Oh my god. I don't know. I feel like I'm gonna be needing to do a lot of Googling in order to do this question. I might just end the video here and then I'll come with a solution tomorrow. I mean, I'll attempt it for the rest of my remaining time, but I'm probably not gonna be able to solve this. I'm just not familiar enough with trees, which is probably something I should learn. But okay, yeah. If y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. I'll come back with the solution to this tomorrow, guys. But overall, good contest. It is a Div 4. We got all the way. We solved the A through E. I'm happy with that. But yeah, see ya.